Hi everybody, my name is Michael, and today we're going to be talking about the CNC milling machine, and particularly one that's running a GSK 980 MDI. So this particular controller is uncommon. It's a controller made in China and has very little documentation. So for those of you out there who have a similar controller, this tutorial is meant to help you get around some of the difficulties that we experienced while trying to figure out how to use this particular controller. All right. On this particular controller, as you can see, there are a few buttons, very large buttons that have been broken out, and clearly most of these things are written in Chinese, but this button turns on your machine and this button turns it off. I really had a lot of difficulty figuring this out, and now it's so obvious. Right, so once you have successfully turned on your machine, you will be greeted with this interface, and we're going to walk through how to move your axis around in this first tutorial. Once your controller turns on, you will be greeted with this interface. And in this particular session or tutorial, we're going to be moving the axis of our machine around. To do that, there are a couple of buttons that allow you to move in various modes. All right, so these buttons are here, these two. These buttons allow us to move or jog our controllers or our machine's axis around. Okay, to move your machine's axis manually, you would press this button. Okay, and then from there you will be able to use any of these keys to move the machine axis around. So to move in the X direction, we could press this button, and then as you can see, the machine is moving in the X direction. It's also visible over here. It's moving in the X direction. You can also do for the Y direction. Oh, we had an alarm over there. And then you can also move in the Z direction, up and down. Right. Now, if you look carefully, okay, you realize that the axis of the machine is moving slowly. You can speed that up by pressing this button. Okay, so this puts us in a rapid mode, and once I press this button, you probably notice that one of these four buttons also came on. So this puts us in rapid mode, and this is rapid by 1,000. This is by 100. This is by 10, and this is by 1. So I'll quickly demonstrate 1,000. So we're going to move our Z axis up, and then you can see that it moves really quickly, right? If we did 100, then it would move a little bit slower. And then if we did 1, then it's even slower, right? You can turn rapids off by pushing the button again, and then you'll be out of rapid mode. While we're here, we're able to jog our axis. So by pressing the Z axis, you see that our Z axis is moving up, and then we can move it down, and we can move it left, and then right in the X axis, and then we can do the same for the Y axis. Right, so if while we're in rapid mode, this is rapid by 1,000, if I wanted to move our Z axis up, and I press the button, you see that Z axis moves faster. And then if I wanted to come down, it rapids much faster downward. Okay, you can do the same for X and then Y. You can also select any of the different rapid overrides, and then, for example, this is 100, and you can see that the machine is moving slower. And then if rapid, by 1, you see the machine is moving even slower. Right. While in manual mode, we have course control over our machine, and then if we wanted finer control, we could press this button to put us in pendant mode. That allows us to use the pendant that came with our CNC machine to control the axis of the machine. Now, if you get in a little bit closer, you would notice that there are a few knobs on this controller. So this gives us control over the X, Y, Z, and then a fourth axis. But in our case, there's no fourth axis. And then the other knob gives us various overrides. So we have X1, X10, and then X100, right? These allow us to slowly move our axis around. Okay, and then this large button allows us to basically jog the machine's axis around. So I'm going to demonstrate how fine we can adjust our axis using our pendant controller. Okay, so we can move the axis of our machine using the hand wheel given. So by turning the hand wheel, you can see that our axis, the x-axis, sorry, the z-axis is moving up or down, right? And then if we wanted to control the y-axis, we would switch to y, and then you can see that our y-axis is moving. We can do same for x. And there you see, x-axis is moving. And we can change the various feeds. It's going to be a little bit hard to see, but we are moving rather slowly, but it certainly is moving. So every once in a while, okay, while you're running the CNC machine, there might come a time where you need to write like a short piece of program just to test an axis or troubleshoot the entire machine. And to do that, you'd want to be in MDI mode, or manual data input mode. Okay, to enter manual data input mode, you would press the MDI button, which puts you in MDI mode, and then you would press the program button. Okay, so underneath here there are a few soft keys that you can access using these white buttons. Okay, so this, by pressing this, you'd be in MDI program. All right, and so we're going to write a very simple tool change command that will change the tool from one tool to another. So this is helpful whenever you need to troubleshoot the machine or test a line of code just to make sure that it's functional. Okay, so we're going to do a tool change, and for tool changes, right, you would use the command M6, and then the tool that we want to change, the current tool is T2, okay, and then we're going to change to T4. So the space button, and then T. Where's T on this? Where's T on this button? T4. Right. Once you're done typing your command, you can press this key, which is basically enter key, to enter the execution cycle. Okay. If you made a mistake, you would press this key to get back into edit, and then you can type whatever or correct whatever mistake that you made while you were typing. So we're going to go ahead and then enter the program mode so that we can run this program in MDI mode. So this command will switch the current tool from T2 to T4. And to do that, you would press your cycle start. I hope this works. Once you have pressed the enter key or data input key, you would press the cycle start, and then the program will execute. Okay, and there we have it. We have just done a tool change from T2 to T4. So we want to change from tool 2 to tool 5. We have entered the command M6 followed by T4 command. So we're going to be changing that. To be able to do that, right after entering your command, you would press the data input button, and then this puts us in the mood that allows us to execute this particular command. So you can see that the screen is grayed out, and to execute, you would press either this green button, which is the cycle start, or this big green button. It's basically the same thing. So I'm going to press this one, and then we will execute a tool change. Great, and so we have successfully changed from T2 to T4, and in your various in the various CAM programs, you can do this, and then this can be done automatically while your CNC program is running. Okay, so we have successfully changed from T2 to T4, and then you can confirm that over here at the top of the screen. As you can see, we are now in T4. Tool changes are usually handled inside of your CAM program and are done automatically once your program is running. But MDI mode allows you to quickly test various programs that you're not sure about, or sections of your code that don't seem to run, so that you can troubleshoot them. Hello again. So in this particular tutorial, we are going to be talking about how to mount your workpiece and find the edge of your workpiece. Now, finding the edge of your workpiece is very important because inside of your CAM program, you need to specify exactly where your machine's starting point is in order to be able to get the best outcomes from your mill process. So in this particular tutorial, we are going to find the edge of our workpiece precisely. And for that, we're going to be using this tool here. It's called an edge finder. It's already been mounted into a tool holder. Right, an edge finder has a precision ground ball point that is ground to exactly 10 millimeters, and we can use that to find the exact edge of our workpiece. So we're going to mount our stock inside of our bench vise, and I'm going to open the bench vise. Normally you'd mount your workpiece with a set of parallels, but for this tutorial I'm not going to use any parallels. I'm just going to eyeball this, and right. So I have my workpiece secured, and then I'm going to tighten the vise. Vise is tight enough, and always remember to remove the handle from your vise. Okay, Now that my stock is secure, I'm going to jog my machine Z-axis up, and to do that, I'm going to put myself in manual mode, and then I'm going to do a rapid. Put myself in rapid, and I'm going to do a rapid up. Good. Once I'm a fair distance away from my stock piece, I am going to remove my tool. You can do this by pressing the green button up here, right here, and that should release my tool. Now I'm going to insert my edge finder. Again, you press the button, and then you release, and then make sure that your tool is secure and won't fall off. Okay, right, now I have my edge finder in place, and now we're going to find the edge, which is exactly here, of our workpiece. Right, to do that, we will be in manual mode again, and then we're going to jog our axis as close to the edge as possible. I'm going to slow this down a bit more, so I move slower towards the edge. So once I'm close enough, I am going to put myself in pendant mode so that I have final control over the movement of my machine. So I'm going to start by moving my Z-axis down. So we get as close as possible. It's important not to crash your workpiece into your edge finder. And so we'll move as slowly as possible, just so that we barely touch the edge finder, and then we can move to the finest X1, and then jog again. Okay, so just as soon as your edge finder touches your workpiece, you back off by a hair. All right. So once your edge finder has touched your stock piece, you will come into your tool offsets by pressing this button. Okay, and then using the soft keys, you would press offsets. And in our case, we're setting the edge for the G54 coordinate system, and so we'll use our arrow keys to move to our G54 coordinate system. And this particular axis that we're setting is our Y axis, so we're finding the edge of our Y. Now, you would push the soft key measure input, and then enter 5, and then press input. Okay, right. So now you would realize that our G54 and our machine coordinates are only 5. The difference between our G54 and then our machine coordinate is only 5 millimeters, and I'm going to explain why that is in just a moment. So once you're done entering all of that, you go back to your manual mode, And then the first thing, and this is very important, is to move your z-axis out of the way, basically moving your edge finder out of the way. So I'm going to move my z-axis up and clear off my stock. Once we're clear from our stock, we can move any other axis. So in our case, we're going to move our x-axis because we're going to be finding the edge of our x-axis, and then y. Again, we're going to locate our edge finder as close as possible to the x-axis. Right. And then we're going to get closer. Are you able to get from there? All right. Once you're close enough, we will put ourselves in pendant mode and set our pendant to X, and then we're slowly going to jog our axis towards the edge finder. So again, once we touch the edge finder, we back off by hair. Okay, so that's great. Back off. Good. So again, we're done touching off on the edge finder. We're going to come back to our tool offsets mode. Should I keep it? To our tool offsets mode. If for some reason you are out of that mode, you would come back to tool offsets. And again, we're setting for G54, the G54 coordinate system. And so we'll move our arrow to the X axis, and then we will press the soft key measure input. And then we're going to enter -5. And then press data input. And again, as you can see, the difference between our machine coordinate system and that of the G54 coordinate system is 5. Okay, and I'm going to explain why that is in a bit. First, I will I'll enter manual mode and then move my z-axis clear of my stock. Right. So let's explain why we had to use 5 and -5 while finding the edge of our part. Now, when you take your spindle and imagine a line running right through the center of the spindle, through the edge finder, that line would divide this sphere into exactly 2. Okay, so if the sphere is 10 millimeters, then the distance between the edge that is touching your workpiece and the axis of the spindle would be 5 millimeters. Okay, hence the 5. Now let's explain why in some cases we're using a -5, and for example, in the X, we're using a -5, and then in the Y, we're using a +5. Now, the CNC machine has a coordinate system, so there are movements that are in the negative direction, and then movements in the positive direction. For your X-axis, when you move left, that is considered movement in the negative direction. So by moving left, we are moving in the x negative direction. And then by moving right, we're moving in the x positive direction. Now, by moving for the y-axis, by moving down, we are moving in the y negative direction. By moving up, we are moving in the y positive direction. Now, this is important because once you have touched off here, to get to, on the x-axis, once you have touched off on the edge, to get to the central axis of the machine, you'd have to move -5 or move 5 in the negative direction to get to the central axis of the machine. And then, so, see if I can quickly, but yeah, quickly do this and quickly do this. I hope I don't crash my machine. Right. So assume we were here, and then this workpiece was touching the edge finder. To get to the axis, you would move in the left direction, or x negative. That would bring you to x -5 would bring you to the exact axis of the machine. All right. So that's why we had to enter -5 so that when we go to home our machine, or 0 on our part, the stock would now move in the x negative direction by 5 to get to the axis of the spindle. And for your y, again, clear your edge finder, make sure it's not touching or in the way of your stock. In the y, back down. If our probe is touching this part of the stock, then in order to get to the axis of the spindle, would have to move in the positive direction, meaning y plus 5 to bring us to the axis of the machine. And so if we execute this, the probe should sit right on the edge of our workpiece. And so I'm going to put myself in MDI mode, and then we're going to write a simple G-code command to test this out. Again, lift your probe out of the way and make sure that you don't crash your probe into the workpiece. Okay, so we're going to write a simple G-code command to test what we have just done. So to do that, I'm going to put myself in MDI mode, and then I'm going to press on the program button and then use the soft key to navigate to MDI program. And see, our previous code is still there. We would put ourselves in edit mode by pressing this button, and now we can edit our code. So I'm going to delete all of that, and then we're going to enter our very own G code. All right, so to do that, I'm going to put myself in absolute coordinates, and to do that, we'll enter the command G90, and then we will come down, and then the coordinate system that I want to work in would be G54, and then we'll move to the next line. And I'm going to now move my X and Y axis. To do that, I'm going to do a rapid. That's G0, G0, followed by the positions that I want my X and Y axis to be. So I'm going to put my X at 0, and then my y at 0 also. Okay. Once you're done finding the edge for your x and y, you need to find the surface or the position of the surface of your stock piece. Okay, to do that, there are a number of ways to do that, but for this particular tutorial, we're going to use the paper trick. This assumes that you do not have all the tools required to find the surface of your workpiece. So to do that, we're going to start by removing our edge finder. And the edge finder is gone. Going to replace that now with our end mill. So we're going to insert an end mill. Always make sure your tool is secure. And we're going to jog now our axis. So while in manual mode, we're going to jog our axis. In my case, I'm going to use a piece of paper, and then I will put myself in pendant mode. Drop my pendant. So this can actually be a shim, a piece of shim stock that you have lying around. I don't have that, so piece of paper. And then we're going to jog our z-axis down. So you move the paper around. This could be shim stock that you might have around, and you can jog this slowly just so that the paper catches on the end mill. Once you have that, you are good to go. And then once you're in this position, you would come and then press the offsets, and then you would scroll down to your z-axis. I've already done this. You scroll down to your z-axis, press the soft key measure input, and then press 0, and then press enter. And there you have it. We have successfully found the edges of our workpiece and also surface of our workpiece using our CNC mill. And so in other tutorials, we are going to talk about how to start milling the face of your material and the other various processes or machining techniques that you can utilize.
My name is Kobe. Michael already went through some of the basics on how to start up this machine, run through a bit of the tool changes and the MDI commands and some of this stuff, and then finding the edges of a part for your work coordinate system. I'm going to go through tool changes or tool offsets so that we have the links for our tools correct. I'm going to go through some basic changes you need to make to your G-code file in order to load it in here, then how to load it, and then ultimately how to run your G-code file. So let's just jump right in. First thing is we'll do, I'm going to load a tool. Before we load a real tool, we want to use a positive tool length offset strategy. And the way we're going to do that is zeroing the head of our spindle on a known datum. In this case, just the top of this arbitrary piece of squared off aluminum we have. So we'll set that tool length at 0 for the spindle head, and then add tool lengths for each of our set tools to that dimension. So first thing we're going to do is we're going to load tool 1. So it's going to put away the current tool into our tool carousel. Load tool 1. In this case, we're using tool 1. It's kind of a fake tool. We're going to use the spindle face as our tool 1 length. We have 16 pockets in this tool changer. Tool 1 and 3 and a couple of the other ones happen to be broken. So this is a perfect opportunity to use that as our zero tool length setting. So we'll go to our tool offsets. Oops. Tool offset button here. And jog up to T0. And we'll use our hand wheel by selecting our hand wheel, hand jog button here. And with this set to Z, we'll move our spindle down close enough. With no tool in the spindle and the tool changer saying tool 1 in our case, we're going to move that spindle head down until it's very close to the workpiece we're using to set our tools. You could use a 1, 2, 3 block in this case. You could use any piece of square stock, something that is flattened nicely. And you're going to get close to it, add a piece of paper, go down to smaller increments, and then just jog down until that spindle face clamps on a piece of paper without ripping it. You want to be able to pull that out, but you don't want to add a whole lot of force onto your spindle. At that point, we're going to come back to our controller and set our spindle face as T10. So with our Z0 or the T1 in, we want to zero the spindle face. So we'll hit Z-axis measure input, 0, enter. So now our T0 is set, or T1 in this case actually, is set at that 0 point. Once that's done, we can start actually setting our real tool lengths. So what I'll do, go back to my MDI. Change to tool 2 in this case. Run that tool change. Tool 2 is our 6mm drill. So now that's in the spindle. We'll go back to offsets. First thing we can do is enter our diameter as input that input 6, input that measurement. So that geometry in diameter for tool 2 matches what we actually have. For our length, we're going to measure in reference to what we had before. In this case, it's in reference to our position of the machine. So again, first things first, we're going to put it in 100 speed in our hand jog mode, or our pendant jog mode, and we're going to move down until we're close. Just like we did before, moving this down. We don't want to touch it, but get quite close. Add our piece of paper. Change our increment to either 1 or 10. In this case, I'm going 1. We're going to move that down. As we do, moving that paper back and forth. Until it clamps. Once it does, we'll leave that there, come right back to our controller, and we're going to measure z-axis, measure input. 0, enter. And now our absolute coordinate system number matches where we are in relation to that z. Once we're done with that, we can go back to our MDI mode. We're going to do the same thing again. We're going to move to, hey, how do I edit? Edit that tool path again. You can edit that when I'm touching all the buttons. You can edit that out. We're going to delete our 2, add a 4 in here, and we'll run that program. So same thing again. We're just going to do a simple tool change. If we roll back into offsets, we're in T4. We've already set the 20 millimeter geometry. The next thing we'll do is again go down, pendant jog mode, or else this isn't going to do anything. We're going to get that nice and close. Careful not to clamp your fingers. And then move to the 1x increment. Until that clamps. And then we're all set. So we're going to go back once again, back to our controller. And we're going to z-axis measure input. Right now, these two values are similar because we've done this once before, but they're not exact. Once we hit this measurement and 0, and then input, those go to the same. If you wanted to be even more precise about this, you could get a pair of micrometers and measure your paper. And then instead of saying 0 when you input, you would say the thickness of that paper. We're going to be a little bit less precise in this case and skip that section. But you could put in, and if you wanted to put in a feeler gauge, a known thickness feeler gauge, you could also do that. Go down until it clamps a 1/10 of a millimeter feeler gauge. Move that until it clamps, and then add 0.01 or 0.1 in that case instead of 0. Whatever you want to be your feeler. Paper is so thin, we call that good enough for what we're doing. If you wanted to be more precise, you're working on something ultra accurate, making sure those offsets are perfect, you'll go with something more precise. So if you have even more tools in your tool changer, you're going to want to, or in your program that is, you're going to want to go ahead and set your tool lengths and your diameters for every single one of those tools. Our program that we're working with right now only has that 20 millimeter end mill and the 6 millimeter drill. So those are the only two ones we set. The reason we skipped tool number 3 is because that pocket in our tool changer is currently broken. We're waiting on a part to replace that. We've programmed all our tool pathing in Fusion 360. So for this part, all it needs to do is a simple facing operation with our 20 millimeter tool, and then 3 drill holes, in this case at 2 different depths with that 6 millimeter drill. So we'll go select our setup, hit post. The post we want to use is essentially just a generic Fennec CNC post. We will upload the actual post processor we're using in a link. We'll give it a a file number. In this case, we'll just go 1055. And here's the trickiest part that took us the longest to figure out. All the files that worked looked like it was a 5-digit number starting in 0. In fact, it's a 5-digit name starting with an O, a capital O. And the letter O, not the number 0. If you put a number 0, it will not show up. And that's something that we struggled with for a long time. So just make sure that the file name starts with letter O and then 4 numbers. That's the only way it shows up. And we'll hit post. Once we have, this is one other thing we have to go and change. If you ask the distributor for this machine, they'll tell you in order to run G-code on the GSK machine, you have to, in their words, change something in the header and at the bottom of the G-code. We finally figured out what those are. First of all, the G20 or G21 command, typically that's used to switch between metric or imperial or metric or inches units. The GSK controller doesn't want you to tell it which units to use. You've set that already. It doesn't want to hear it again. It will not take a G20 or G21 command, so it has to be deleted out. So in addition to getting rid of the G20 or G21 for the units, you also have to get rid of any M27 command. So I'm finding that in this case there's 2 M27s. They're typically at the bottom of each operation, and we'll get rid of both of those. And then it also, the Fennec post processor saves as a .nc file. Our machine wants a .cnc file. So we're going to go all files, save as a .cnc, and then save. So that's just doing a save as. Once we have, then we've got letter O 1005.cnc. We can now drag that onto our pen drive, USB, and bring it over to the machine. Once we have our file on the pen drive, our USB port is behind this small door. So open up that door, plug in your pen drive. Should be simple enough. Your USB drive will show up here in the file management, which is this button over here. Open up the USB drive. With your arrows, jog down to 1005. What we want to do is copy into CNC. The thing you will want to make sure is that you're in edit mode. If you're not in edit mode over here, it won't copy that. So if you're in run mode or MDI or anything else, it won't. Make sure you click edit first, then copy to CNC. It will say successfully copied. We'll go into our local drive. Just as a side note, you could be running this this file from your USB, but then if something happens to the USB, it gets knocked, it gets broken, or if it's too slow, your machine won't be able to keep up. It's always best to copy those files onto the local drive before you run them. So once we've done that, we can open that file. Here's that G-code. If we wanted to, rather than editing where we did on the computer, we edited the G20 or G21 and also the N27s. We could be deleting those here in the edit mode. I find it's easier to do it on the computer, a little faster. If you forget to and you don't want to go back to your PC and do that, you can always edit that G-code directly on the machine. Once we've done that, now we're ready to go. We can cut this part. Before we do, I'm going to change that stock out to something smaller. We have a really tall piece of stock. Why don't we go ahead, change this out. So we'll put in this small piece. If you had parallels, that would be great. We are running without parallels right now. So we'll put that piece in, lock your vise down real tight. The thing has changed now is our work coordinate system. So we want to make sure we go back and set that offset. We'll do it with T1 in the spindle. What the heck? Go to offsets. G54, we're going to set all three X, Y, and Z again. In this case, we'll use our end mill for Z. So we'll jog down to Z in the handle jog, or the pendant jog rather, pendant jog mode. Jog down until that touches. Again with our piece of paper. Oops. Get that until it touches. And measure input, 0. There's our Z. Michael's already done this, the edge finder in X and Y, but we changed the part, so we have to do it one more time. Take our tool out, grab that edge finder, and add that in. We'll move over in X until we're safe. Down in Z until the ball is below that surface. X, we're going to approach very slowly, our smallest increment. Until that touches. Once that edge finder ball touches, you can move off by one click so it stops beeping at you. Hit measure input. We know we're 5 millimeters away, and we want to tell it that we're 5 millimeters away in the negative direction. So we're going to put -5 input. So absolute coordinate system, we're 5 millimeters away. And we can see that the difference between our G54 and our machine coordinate system is 5 millimeters. That's how it should be. Now we can do the same thing in Y. Oops. So I'm going to move up in Z until we're safe. Away in X. Oops. Then we're going to move so we're safe in Y. Oops. So we'll bring that in really slowly in Y. Just until that ball touches. Make sure we're actually moving. Yeah. And I move off by one click so it stops beeping at me. Off in the positive direction. So when I hit measure input, we're going to get 5 input. Let's double check our zeros. We can do that by going up in Z, E, up in Z, and just watching our absolute coordinate system, let's go until that reads 0. It can be really close. It doesn't have to be exact. And then our Y in 0. And if you're not 100% confident, as I often am not, the best thing is just to jog to what should be 0, 0 or XY 0 according to your machine or controller, and then check in the machine. Are we actually at what looks like 0, 0, where our spindle is aligned with the corner? In this case, yes, we're good. So we have properly set our X, Y, 0. We did our offset with that tool for Z. We can take our digital edge finder out one more time, put it in a safe position. We're loading physically load our tool 4 again. And finally, with all our axes set, program set and edited correctly, our tool lengths are all set in the controller. We're now finally ready to cut. We're going to put it in run mode and in single block. Single block will allow us to run through only one line of code at a time with each press of the cycle start button. We'll close our doors and hit cycle start. It'll begin our program, and we'll keep going down in lines of code. The first thing, tool 2 is loaded, but it needs tool 4 first, so it's going to do a tool change. So we can watch it go down. It'll orient the spindle properly, bring in our umbrella tool changer, move up, change our tool. It's going to switch into the next tool, down, load that tool, and move our umbrella tool changer out. We can keep hitting cycle start. The next thing is starts our spindle, starts our coolant. We're going to wait for that coolant to flow and start coming out before we move on. Sometimes it takes a little while. We want to make sure we're not starting that program before the coolant starts to flow. So once that's going, we can keep moving down in our program. And finally, we're cutting material. We're going to leave single block mode. And with that cutting tool, time. Our step over is set appropriately. This ensures we have a really flat, even datum surface. After it finishes that facing operation, it's going to turn off that spindle, move back up, orient that spindle again. Oriented, going to change our tool again. Drill those operations. So now that it looks correct, we can leave single block, and it's going to drill those holes. Move over, drill the next hole. And drill the third hole. Once it's finished, move up, turn off our spindle, and the program is complete.